Hello everyone, this is Soumya. I'll be discussing Maths 1 with you all. So let's start with the basic number theory. So the very first term is natural numbers. What are the natural numbers? The numbers which start from 1 to infinity. This is what we have studied in school, but IITM considers 0 also as a natural number. So keep this in mind. Next we have integers. So all the numbers, all the negative positives including 0 are considered in integers. After that, we have rational numbers, the numbers which can be written in the form p by q, and q is not equal to 0 are your rational numbers. Okay. Next, what are irrational numbers? The numbers which cannot be written in the form of p by q. For example, pi, e, root 3, root 2. And if we have negative root, it means negative value in root, that means it is a complex number. Okay. Then what are real numbers, which comprises of all rational, irrational numbers, integers also. Okay. Next, they have defined a term factor. If I am saying that a is a factor of b, that means it is completely divisible without leaving any remainder. See, these are the basic terms, so I'm just quickly going through them. Next, we have prime numbers. Prime numbers are the numbers which are divisible by themselves and the number itself. Okay. After that, arithmetic operations. You are aware of four basic arithmetic operation: addition, subtraction, division, and multiplication. So what to discuss in that? Next, we have modulus operator. It gives you the remainder. If I am saying that 16 modulus 4, that means my answer will be 0. If I say 17 modulus 4, it will give 1. So it basically gives remainder. Next, we have GCD. For this, you must be aware of prime factorization. So we are given an example. We have to find GCD stands for greatest common divisor. I hope everyone knows. We are required to find the GCD of 18 and 60. So we'll do prime factorization of 18 and 60. 18 is 2 into 9, and 9 can further be factorized as 3 into 3. 60 is 12 into 5. 5 cannot be further factorized, but 12 can be written as 2 into 2 into 3. Now the common prime factors are 2 and 2 into 3. Okay. Next we have, okay, so our main topic sets start from here. Set is basically collection of items, and this collection can be of anything. Collection can be of the books you have read. Collection can be of players of the current cricket team. Collections can be of days of a week, factors of 24, primes of 15, anything. Sets can be finite or infinite, and the order does not matter in set. If you're writing any of the elements first, any of the element at the last, it does not matter. Duplicates also does not matter in set. If you are repeating any element, it will not change the set. Next we have cardinality. This is a new term. It means the number of items present in the set. Okay, and it is only defined for finite sets, which is very obvious. Next we have, yes, items in a set are known as elements. Okay. Membership. If I am saying that small x belongs to capital X, that means my small x is the element of capital X. Next we have subset. Subset is denoted by this symbol. If I am saying that x is a subset of y, that means it will be denoted like every element of x is also an element of y. But there is a term like proper subset. In that case, we don't put this equal sign. This is only written when x and y are not equal. Okay. Empty set is a set which has no elements. It is denoted by phi. Powered set is set of all the subsets. So if I am given a set X and I am asked to write its powered set, how will I write? I'll write phi first because it is set of every set, then A, then B, then A comma B. So powered set is denoted by 2 raised to power n, where n is number of elements. Next we have set comprehension. It basically tells how do you read the set, how do you comprehend it. If I say that my x is an element of z and x mod 2 is 0, modulus gives remainder. If any number is divisible by 2, that means it is even, that means it is a subset of even integer. Next, it's your task to comprehend these. Okay. Next we have intervals. If I am writing like this, I am Using square bracket, that means my both endpoints will be included. If I am using round bracket, that means none of my endpoints will be included. For like this, you can write left open and right open also. Next, we have union. Union is basically combination of set A, B, C and C, D. These are two sets. If you're asked union, you'll denote it by capital U. And if any of the elements is repeated in the union, you will not write it twice or thrice. You'll write it just once, like this. Intersection is denoted by inverted U. It means you just have to write the common elements. And set difference, it is either given by this sign or slash. This means you have to write the elements of first set which are not present in set. You can go through the examples. Next, we have complement of set. It is denoted by, like I am saying, complement of x, so x bar or a small c above x. So see, we have a universal set which contains all the sets of the universe. So if I am writing complement of set, that means you have to write the elements of set x which are not present in no, sorry. If I am saying that complement of set x, that means I have to write the elements present in universal set which are not in set x. Okay. See, this is the diagram where you can relate all the mathematical objects. Like R is a set of real number which comprises rational number, which comprises integer, which comprises natural numbers. Okay, this is already done. You can go and read more examples. Next, we have counting problems. For example, in a class, 30 students took physics, 25 took biology, and 10 took both, and 5 chose none. Then how many students are present in the class? For this, we need to draw a Venn diagram. So this is our universal set. I'm a little noob at drawing, so just don't judge. This is for physics, this is for biology. See, whenever you are asked to draw a Venn diagram, start drawing from the last line. Like 5 took neither, that means it will 5 students will be here. This is 5. Oh my god, my 5 doesn't look like 5. I don't know what happened to the screen whenever I'm touching them. Okay. 5, okay. Yeah. 10 took both, that means 10 students will be here in the intersection part. Next, we have 25 took biology. See, total 25 students took biology, 10 are already here, so here only 25 minus 10, that means 15 students will be. 30 took physics, 10 are already here, that means only 20 students will be. Now I am asked to find the class strength. It will be 20 plus 10 plus 15 plus 5, that is 30 plus 50. Similarly, in this 55, a class of 55 students. Okay, I am told the strength this time. 32 took physics, 11 took both physics and biology, 7 took neither. So how will I draw? This is my universal set. Physics, biology. Start from the last sentence. 7 took neither. Okay. 11 took both. So 11. This is for physics and this is for biology. 32 took physics. Okay, 11 students are already here. So here I'll write 32 minus 11, that is 21. And I have to find the number of students who have chosen biology. I'm already told the class strength, which is 55. So 55 is equals to 21. Why can't I write? Wait. Just add 55 is equals to 21 plus, I don't know what's happening. I can't write. Just add 55 is equals to 21 plus 11, which is 32, plus 7, which is 39. That means 55 minus 39, which is 16. And means 16 students took biology. Okay. Next we have ordered pairs. So are ordered pair really important? Not always, but sometimes they are important. For example, you are given these points 2 comma 3 and 3 comma 2. If you will represent these points on coordinate axis, you will definitely get different points. Okay. So ordered paired is basically defined as set of two objects together with an order associated with it. Okay. What is the notation of ordered pair? A comma B, where your A is first element, or you can say first component, and B is second component. A comma B is not equal to B comma A. The equality only exists when your A and B both are equal. Now, what do you mean by tuple? This concept of ordered pair is extended further and we get tuple. This is not important now, I'm not going to discuss it. I am focusing only on the terms or the topics which are important for your examination. Next we have Cartesian product. Cartesian product is represented by this. What had happened? Why can't I tell? A. Cartesian product is represented as A cross B. It's not multiplication, it's Cartesian product. A cross B and B cross A is not equal, it is not commutative. For example, I am given two sets. A is H comma D and B is this 1 to 6 numbers. I am asked Cartesian product A cross B. So it will be Cartesian product is formed like you have to write a set in which you have to take first element from the first set and second element from second set. So H comma 1, H comma 2, H comma 3 till H comma 6, and then T comma 1, T comma 2 till T comma 6 will be your elements. Similarly, if I am asked to write B cross A, then I'll write the elements of set B first. So 1 comma H, 1 comma 2 comma H, 3 comma H till 6 comma H, and then 1 comma T, 2 comma T till 6 comma T. This will be my Cartesian product. So you can read this. Next, how are binary relations formed? By Cartesian product. By the subset of Cartesian products are only binary relation. So identity relation in which your both are equal, A comma B is equals to A comma A for all A. This is the case of reflexive also. It is defined for all A. Symmetric, if your A comma B and B comma A is present in a relation, it is symmetric. Transitive relation are the one in which A comma B and B comma C belong to R and A comma C also belong to R. See, I know I'm not giving examples. You must be struggling, but this is just a theoretical lecture and the first lecture. So I'm just giving you theory. You will be taught examples and questions basically, so everything will be. Don't think that you're not getting things or I'm not teaching it. Antisymmetric relation are the one. If my A comma B belong to R and A is not equal to B, that means my B and B comma A should also not be present in R. What is the equivalence relation? Which is reflexive, symmetric and transitive. Okay. And the group of equivalent elements is known as equivalent class. It can be represented in a graphical way. For example, I have a set S 1, 2, 3 and I have defined a relation 1 comma 1, 1 comma 2 and 3 comma 2. This is 1, 2, 3. 1 is defined, 1 is connected to itself, 1 is connected, then 1 comma 2, then 3 comma 2. Next we have types of relations. Empty relation is formed when we have an empty set. Full relation is formed when we have Cartesian product. Identity relation is formed when we have both the elements equal. And inverse of a relation, for example, R is defined as 1 comma 2 and 2 comma 3. If I'm saying R inverse, that means I should get 2 comma 1 and 3 comma 2. It means both components should exchange their place. Then this is already covered. You can read this is also covered. I think every part is. Now this is how you represent relation in a arrow diagram. These are the two sets A and B and we have defined a relation between A and B. First element is A comma 3, A comma 3. Then we have A comma 5. Then we have B comma 1, B comma 1, C comma 6. So this is the arrow diagram, A to B. will be like this, A3, like this. This is how you represent your relation in Cartesian product. A3, A5, B comma 1, C comma 6, and so on. Okay, so in read these, I have already covered. Next we have functions. So function basically give a rule to map input into input and output. Basically we have three terms: domain, codomain, and range. Domain is the set of all the input values. Codomain is the set of all the possible outputs, and possible outputs means only the outputs which I am getting by putting possible values. Okay, and range is the actual output. How do you define the function? It is defined like this. So if I am saying that f is defined as x to y, that means my x will be domain and y will be codomain. Okay, now our line is represented by y is equals to mx plus c, where m is slope, c is intercept. So if I am writing f of x is 3.5x plus 5.7, that means my 3.5 is slope and 5.7 is intercept. And how do we get the intercept? It is a point where the line crosses the y-axis and x is equals to 0 at that time. Okay, so then go with it. Next we have types of functions. So the first type of function we are going to study is injective function. It means that different inputs give different outputs. It is a one-to-one function. That means if your x1 and x2 are not equal, f of x1 and f of x2 will also not be equal. Okay, next we have surjective function. Here range and codomain are equal and it is an onto function. Okay, next we have bijective function. The functions which are both injective and surjective are your bijective functions. Okay, then how do you find domain of a function? Suppose you are given a function under root 2x minus 8. Now you know it is a square root function, it should be greater than or equal to 0. So you'll apply this condition and you will get x greater than or equal to 4. That means domain will be all the real numbers greater than or equal to 4. Now how do you find whether a given relation is function or not? So if my a is connected to many b's, it means if my one input is giving many output, it is clearly not a function. But if my b has many a's, that means I am getting one output from many of the inputs, that means it is a function. Injective function, b can't have many a, that means my one input is giving one output, it is function. If my one output is obtained from many inputs, it is again a function. Similarly you can see bijective. So you can go through the notes. Okay, I think it's done. Now these are again sets now which are already covered.